So when XPeng's CEO had to literally unzip his humanoid bot on stage to prove it wasn't a person in a costume, the world realized we had crossed into an entirely new era of humanoid robotics. Chinese robotics companies are fast catching up with the likes of Tesla, Figure, and 1X, and we've got a courtside seat to the fascinating race for humanoid dominance. Thanks to my guests today, Scott Walter and Gustav Andersson. Scott is a mechanical and aerospace engineer and two-time founder of robotics companies. Gustav is a hand surgeon and associate professor of anatomy in northern Sweden. Welcome, gentlemen. It's time to explore the uncanny valley of Chinese humanoid robots.
Hello, Rock. Hello, Scissors.
Nice seeing you, Paper. Feels like it's been a while.
I'm doing the Optimus sway here, so I don't know if you noticed that this is kind of
rolling on your feet.
Does when it's standing on. It's also good for the blood circulation, so
that's why you don't want to faint on stage.
Yeah, exactly.
I need to get myself one of those standing desks.
Yes. Well, now congratulations, Roy. I think you may have been one of the first Westerners to actually pronounce XPeng correctly. I think. For those English speakers out there, no, it's XPeng is the way we would say it. But there is, for our Chinese speakers, we're trying to become a little bit literate and actually get the name correct.
Yeah, and we apologize for
I might have butchered it a bit.
we probably did, but it's the effort. That's all that matters, right?
That's what counts.
Yes.
All right.
We're literally a bit tone deaf when it comes to that. Okay, we just can't quite get the sounds right.
All right. So you've got a lot to enlighten us about, right? Today, you've done a deep dive, as you always do, and we're so appreciative of everything that you do. So please take us to everything that you have for us today.
So this is probably about my third hot take. So maybe I'll actually get it right this time, because there's still a lot of things you keep on discovering along the way. So I think the first thing I'm going to do is sort of show what was the actual reveal that was on stage and what the impression was. So this comes in two steps here. This is first a video that they showed, and then they actually had the done live. So right now, this is what they were just sort of showing as a preview or what you're about to see. And of course, what's your impression when you're watching the bot?
Yes, I mean, I actually never thought it was a human in the beginning. There were these uncanny valley moments, but often it was something like, it moves too rigidly and it's not breathing. So either it's a very well trained individual who does not breathe very deeply, but I was.
That's what I thought.
Impressed right away. It's like
that's the advantage of being an anatomist and a doctor, is that you would probably notice those subtle things. So now this is a live presentation. So so here it might be, maybe they could only video the real bot, but on the stage they don't. They're not quite sure. And when you kind of look at it, the first thing is this catwalk, and a catwalk means literally 1 foot in front of another is what you're doing there. But the catwalk is not perfect in that there seems to be one side preference. So it looks like the right foot has no problem getting right in front, but the left foot, not quite. And I wonder if that's just like a mocap of whoever the person was doing it, and an artifact that comes in there or something else.
Interesting.
And so there are these little things that make you think, it's got to be actually a human. But more than enough things that you can see.
You look at the hand there, it's like, is it an amputee who has like a bionic hand? Really cool.
Exactly.
That gluteus maximus.
Yes,
that got me confused.
Okay, and we'll get to that. We'll get to that part for sure. But I mean, many ways, the argument could be, but if you get a really good actor, they could, a dancer is able to behave robotically, and you can. It's like, okay, I had no doubt that it was the real thing. Partly because he almost planted the seed, and I think he planted the seed because Elon had sort of talked about the V3. Almost, will almost think it's a human in there. And so he probably thought, hey, this is a great idea for my presentation. And he planted the seed, but he said it's not. And I will take his word for it, because I think for overall, when I listened to a lot of his presentation, he was being very frank. He was not exaggerating a lot of things. And actually, in many ways, it's kind of downplaying a certain technology. So it's like, plus, a CEO just doesn't go out there and make a statement like that, which will, like 2 days later, people are able to prove publicly is like absolutely false. So it may have been, he knew exactly what he was doing here. And remember, it was a multi-day presentation. So he let social media do its thing for 24 hours. So that worked out. My only question was, because the hands were not the hands that they had kind of revealed, that there was something going on there, that it might be the original Iron and not the new one. So, so just to make sure that let's get over the suspense here and show that what actually happened the next day. So they actually came out and showed that it really is a robotic leg underneath there. They removed a lot of material. And the robot
still here, there were people who were like, "Oh, it's an amputee. They have just given someone with a bionic leg."
And to make it even worse, one of the images they show in the lab, there's actually a wheelchair.
Oh, it is
in there. Oh, that could just add to the whole controversy. Yes, there is. But no, for sure, this is the actual bot. And after seeing this, and I was just say, okay, it is actually the new one based on it, because we had not seen any physical hardware. So I'm almost glad the controversy forced them to maybe reveal a little bit more than maybe they intended to at the beginning of the week. So that kind of worked out to be pretty good. So if we actually get to it, so it's being cut off here. The robot walks off stage, and we'll be able to sort of see. Now, this gives you an idea. That's pretty durable material, I guess, because they're having a hard time being able to do it. And you can find this on YouTube. That just search XPeng. XPENG, and you'll sort of be able to find some, the keynote and also what they did the next day, being able to show this. So yeah, there we go. Going ahead and walking off. So the bot's still able to work even with the skin removed.
Yeah.
And I mean, when they showed it last spring, I think it was, there was a short view of the older version walking. I was really impressed back then as well. So when I saw this, I was like, yeah, it seems like a reasonable development. It's very impressive.
The original one, which was revealed almost exactly a year to this date. So it seems like they always on the same day have this. That bot was just beautiful. I mean, aesthetically, very beautiful. And the movements of it, everything were all very good. So it definitely strutted around like a peacock. I mean, there was no doubt about it. It's just like, it just knows it's one of the best walking bots out there as far as convincing. It's very fast. I mean, we haven't seen it go really quickly, but when he moves, he commands the room. There's no doubt about it. And now the Iron Maiden here is doing the same thing. So this is like the reveal that they then had of showing what's the inside. Now, this is all CGI. And this is why it makes you it's like, okay, everything could be in design, but where are they in the hardware? And so first thing we're going to see, and we'll get into this in just a little bit, obviously the hands. There's going to be a lot to talk about those hands because they look very human-like. We can see a little bit about
those are not the same hands as the walking bots.
Yes, exactly. They're very different. So we don't really have much detail on the hands yet. And if they actually pull that off, those are going to be very impressive hands. But we're getting an idea of what's going on underneath the skin, and it's pretty impressive, just from the CGI. And of course, it doesn't hurt to be able to see some of the hardware itself. And that's what we're going to be getting into to sort of figure out what's next on that. And this was like a 3-hour presentation in which maybe 20 minutes was just about the robot. I mean, they've got so many other products. They talked about not a flying car, but basically a kind of a type of copter, I guess you could say a VTOL, an eVTOL that they've been working on as well. So that's also exciting. Yeah. I mean, there's definitely a lot of things. And of course, just a little bit of the background is because they also produce EVs and they are working on an FSD kind of chip and believe they're also very close to having robotaxis and autonomy and everything like that, are seeing the same thing, that their chip that they call Turing chip, good name, is the same one that they're using in their car and they're doing here. So we can see a lot of parallels here with Tesla as well.
Which I found really interesting because it has a lot of echoes of Tesla in the vertical.
Yeah, absolutely.
Vertically integrated.
But to their credit is they have been working on this humanoid bot project way before Tesla even announced it. So I think they started maybe like 2019 or something like that, or maybe even earlier. So they've been thinking about this problem for a while as well, which is why
they're does it have the AI in place?
Well, that's the thing. They're working on the same autonomy for cars, and they are also developing their own chip, which might be similar to, I don't know, FSD 2 or 3, or we don't know what the level is, but they're kind of doing the same thing.
There is this controversy that wasn't there's someone who sold the old autopilot code to XPeng back in the day. At least that was
something like that.
It's
claim.
possible. So I wouldn't say that they're necessarily ahead on it, but they're on kind of parallel tracks and trying to do the same thing. And the question is whether there's like an advantage to doing everything, owning your own stack, or whether you should be saying like, there's some things we don't have the expertise for, and we should rely on people outside. So the main thing is I'm going to just look at the mechanics, and I can't speak too much about what they're doing in the AI front, except I know that they're doing something. They do something with the training, because that walking wasn't just about the hardware. It was also about the training. Okay. So what we have here next is, we just showed this, kind of a little bit of the reveal of what the skeleton looks like. And, when I kind of looked at it, my first question was like, okay, could you really fit that into the body that we saw? I mean, is there really some way to put everything around it that it would look absolutely human-like? And so it's like, oh, okay, I took one of the frames, made it transparent, and put it over. And you could say, oh, yeah, it looks like you could probably fit it in there with more than enough room for padding everything. That would be very hard to see any of the underlying mechanical structure that's there, and then it fits. So I was like, oh, okay, yeah, I'm pretty convinced at that point that it's not a person in there, and they can go ahead and do it. My only question was whether it was the old one or the new one, and the old one could almost fit in there as well. It was very close. So before we go ahead too far, I want to refer to a principle that I kind of coined back in the spring that probably nobody's heard of before, that I call the in-out principle. And this is your way of, let's say, the best part is no part, and all kind of stuff like that. But how do you decide when the part is needed or not needed? So this is like one more level in there. And as you can see, the idea of the in-out is, keep it in or toss it out. So you try to categorize the function that something is providing for you along these kind of 5 guidelines. And like one, the eye is like it's indispensable. It's like you take it out, it just won't function. So it's like, let's take the engine out of the rocket and see if it works. It's like, no, it's indispensable. Sorry, you're gonna have a rocket engine in there if you want it to work. Needed. It will function, but will severely limit the ability. So there could be lots of things that you could find a way of, like, we don't really need to have a knee in our humanoid robots. They could still walk without it. But you know what? It won't be able to go upstairs or, down on level. There's all sorts of reasons that you would want it. So it's still kind of needed. And then you get kind of the optional, where you're thinking, well, non-essential, but, it could make life easier for a few things. So that's where the debate is right there at the optional. It's like, really, do we keep it in or out? And if you want to go super minimalist, you stick to, pure in. And otherwise, if you're willing to add a little bit more functionality for convenience, you do that. And then you have those that are just clearly useless. I mean, someone thinks it's in there and you say, offers absolutely no practical benefit or purpose. So right now it would be like arguing, my phone should have a DVD player in it. Let's just retrofit, it's just like, it's completely useless. What do you need that for? I mean, there's absolutely no benefit. Actually, that would probably go from useless to the next one I call toxic. Degrades the performance with zero benefit.
Yeah. So the solid state battery that they are planning on putting in all of these, I mean, in my world, isn't that technology not yet developed enough to be even optional? I mean, is it really needed, or is it useless at this stage? Because it might just...
I think it might be somewhere in the optional. We all agree that someday everything's going to be solid state batteries. We just don't know when that day is. And at some point, someone's got to take the plunge. Someone's going to start doing it. And he sounds like they're confident enough in their ability to produce solid state batteries, but not enough to put them in cars. So it's more like, it makes more sense because we don't need as many in the humanoids. And also his feeling is that the humanoids are even more dangerous than cars, as far as batteries. So he's even, more concerned about battery fires and all these other things in humanoids versus cars, which is interesting because I would think both of them are kind of equal. But during his talk, he was sort of going on about that's
he was very honest about that as well. Like, we're not planning to put it in the home, and we're not going to put it in the factory. We're going to do what Royden and Scott and Gustav said, and keep them in the showroom to kind of invite guests, and as we talked about a year ago,
making them entertaining and stuff like that. Yeah, absolutely. So that's.
But I guess that's also a limitation of the of the final product and its abilities, right? And I just want to go back to this framework of yours, the in-out framework. So this is not a static framework, I would imagine, because as technologies
Correct.
develop,
Yeah.
right, features would come and go, and they would go from being optional to indispensable.
Yeah. Exactly. As it
And so
matures and everything else.
where is the iron bot according to you right now?
Okay. Well, what I'm using this more as a principle is that as we go through the kinematics to sort of decide whether they are putting in things that are kind of optional or useless, and like would we put them in what they are. So I just want this in the background because as we go ahead, we're going to see they've made some very radical, very different things. And the question is like, should other people be copying them or not? And so just kind of keep it. Yeah.
Yeah, because I still don't get a particular or a range of use cases for this bot as it is right now.
Yes.
Because for me, the main thing is intelligence, which is the smarts, which is why I asked you, do they have the smarts? Because if not, then it kind of gives me the what's the clone bot vibes. I don't know if you've got the same vibes.
Yeah. Well, not quite. So if we go to the next image I have here, which is sort of the first one where we're going to start, and this is quite an interesting mechanism that's in there. You're looking at it, and the first thing is like, wait a minute, what's going on here? And we end up seeing that from the animation, I'm working the animation forwards and backwards, so you kind of see what's going on. So we are not seeing the standard shoulder motion here. We are seeing what is effectively that's like the clavicle or the scapula kind of moving around
or together. So primarily elevation and depression, I'd say. And maybe a little bit of rotation, but you can't really. Yeah, it should be able to kind of.
It's hard to tell. Yeah.
Or
now, if you look at this, can you see the mechanism that allows that, or where the actuator is for that?
Yeah, so they're in the back, right, where we would keep our rhomboids, as the muscles are called, but they are not in the same level, which maybe it's okay. I don't know.
Well, it means there's an asymmetry, which means there's one side might perform a little bit better than the other, which means you'll have a dominant arm, like us humans have. But they had absolutely no choice being able to do it. However, there's actually one more joint here that may not be seen. So one of them is obvious. Yes.
Is that a limitation of the size of these actuators right now? And if the actuators
Well, part of it could be the stroke. That if they require a certain stroke, it's like, wow. I mean, we have to make it this long because the motor has to probably be almost twice the length of the stroke that you're going to need.
Right.
Because you got all these other things going to be in there. So if you need like a 2-inch stroke in there, it means you need 4, and that's just going to be how it is. The other could be also, obviously density, torque density, stuff like that can also change other things. But when you're going to a linear one, it's a little bit different. Now, a lot of people looked at this and they picked up on those 2 horizontal actuators, but I've seen other YouTube channels where they actually missed the other one that's in there. So there's an additional degree of freedom in here. So I'm going to highlight everything here over on, the right side there. So you can see the blue actuator and how it connects to this yellow linkage. And then you have the green linkage up there, and you see that green axis. That's basically where you're getting that motion when you're doing the shrug. Okay. However, that shrugging is not actually being done by the blue actuator. It's being done by the orange actuator that's down along the side, down the rib cage. So it's actually pointing vertically. So what it does, it's the one that's pushing up on that yellow linkage.
And then pulling down, I guess.
Now it's hard to see from this side. We'll see from the other side that there's a similar green linkage just below what is that shoulder actuator, which is the far actuator or the flexor actuator that makes actually a 4-bar mechanism or parallelogram. So that's the thing that move up and down. There's two points there. So that means the shrug is actually the orange one that's down there. The blue one is the hug. And I don't think they show the hug going on there. Idea that. Now, the thing
protrusion and retraction, as we would call it.
2 different. So this is not a planar problem. And because of that, we have the famous Heim joints. People are probably sick and tired of hearing me say Heim joints all the time, but that's the reality. that they're all over the place. Now, the green linkage doesn't need it because it's designed that those are normal pin joints. But coming off of both actuators there, because the movement of that yellow one is a little bit interesting, you're going to need to have some sort of Heim joint in there. And if I then go to the front one here, and I think I highlight this, we can see, yes, there's the equivalent of the green actuator down there where everything is moving around. Now, it's a little bit hard. I'm going to just kind of back up for a second here to figure out exactly where that hug rotation is, which is the blue axis there. It appears to go through this cylinder here, but it doesn't, because you notice that thing's off at an angle. Do you know what that is? That's where they attach the lift device. So basically the hook where they lift, that's where you screw it in, and basically that's how it comes up. But if you look underneath it, you can kind of see that part of that is this linkage mechanism that has an axis on the top, and there's going to be one on the bottom that's a little bit harder to see from the other side, but it's probably down here somewhere. So it does the hug around there, and then the shrug about the green, up and down. And now let's go. This is definitely not an I or an N. Okay. Maybe we can class, it's definitely O for sure. You know, it's something that's optional, but you can argue, but maybe is it more like U or T? Is it useless or toxic? Because when you look at all the additional stuff that has to go in there, that's payload and mass and complexity that if it doesn't have any value, I mean, does it degrade from it or not?
For me, it's
or
toxic
is it useless?
because, I mean, for me, it's I don't know, it's just so crowded. I have serious questions about the range of motion.
Yeah, but
and if one of those goes out of alignment, you've got a lot of problems.
Yeah, you have, but right, is it more than just shrugging? Is it just about emotion? So hey, our robot can do the shrug emoji now. Is it about that, or is there more value to it? Gustav, you can probably answer that.
Yeah, I'm in the in camp on this one. I mean, you need to reach forward and, I don't know, throw the ball to your kid. You need your scapular movement, and there are conditions where we do
Belgian beer glass in the top cupboard.
At the top of the shelf.
Without having to get up on a step stool to be able to do it. So
we haven't really seen whether or not it can do these movements, though. I mean, can it really do this?
Yes, but from the standpoint, but we have them as humans. We have them. So, and they have value to us. And the thing is, I ask this question to every single roboticist I meet out there. You know, my famous questions: which axis would you take away if it was, if it was too costly, you had to get rid of one, and which one would you add if you could do it for free? And about every one of them says scapula. They would love to have a scapula, but they do feel that it's a kind of parasitic overall and difficult. But they appreciate the whole point of the scapula. Now, if I was like being into robot boxing and in the boxing league and designing one for that, I would put a scapula in there. Not so much that it'd give me a punch, but I might design a scapula which is compliant, so that when I take a punch, it absorbs the energy rather than having resonate through my whole structure. So that might be part of the reason why we have scapulas, but the main purpose is it extends your reach, could also get you a little bit out of singularity in some locations. So it's not useless in that sense. It is optional because it does provide some benefit, and it provides a benefit, and it would be nice to have because it would make life easier, kind of thing. So that's where I am. But Royden, this is the whole thing about it is. It's not like there's any right and wrong answer. It's about stating your case and why you think it is. And it's what every engineer should be debating when they're looking through these things of, you make your case on why you think it's toxic. And maybe other people will go, oh, yeah, it is kind of making life easier. But boy, I didn't realize there is something that is degrading the performance overall that maybe I really don't need it, and I can do it by some other way.
And also, when it comes to what their plan is, at least in the short term, to be more of like a welcoming people into the showrooms, and maybe not actually doing heavy lifting and heavy work. It will be more of an expression part, and I don't know, or give me a hug or whatever. Whereas if they're gonna lift heavy stuff all day long, it's probably going to be one of the things that breaks quite quickly.
Exactly. Because it's going to support everything. So that means you have to over-engineer it. And remember, it's at the very top of the chain. So it's carrying the entire arm. All the load of the arm is going to transfer, which is probably why they have those linkages. And they could make those linkages pretty strong. These 4-bar linkages that will help, and why the actuators there are also pretty robust. I mean, they're linear actuators that will be able to give the stiffness that you need. But that takes space, that takes mass. And that mass means it's going to be less safe, right?
So I don't know if the next step would be, but where does it rotate? Is it in multiple spots or?
Oh, okay. So down here we have this orange actuator, and when that pushes up, it basically lifts everything up. So yes, it's rotating in multiple spots. So the green axis I have there, you could say is the principal one of where you're sort of seeing the whole thing rotate around, but everything else has to because it's a parallelogram. So all because 4 corners have to rotate, but they rotate
like
parallel.
Big cylinder. It looks like it would kind of hit something.
The whole cylinder is going to move. Yeah, so there's going to be enough room for that cylinder in the back. So there's some space for that. So that whole thing rocks around, and so what happens is I think what will happen is it will lift it up without actually rotating the cylinder. That's the advantage of having a parallelogram. If it was like set up as a triangle, then that whole cylinder would have to rotate. But what's going to happen is that cylinder is just going to move up and down. It's actually going to go in and out a little bit. There is going to be a little bit of in and out, and then it's going to go up and down, but it will not change the orientation of it. So that's safe. The only time you change the orientation is kind of what's happening here along the blue axis. That's more or less designed to have the whole thing rotate about that. And so they're doing it in the back, and yeah, it's rather interesting to see how it's being lifted. So again, everyone had the eye on the wrong ball, and and everyone did not notice it was down the rib cage. So this is a 9-degree freedom arm. Yeah, the lats. Yeah. That's exactly. I was trying to come up. Yeah, so the lats are
or at least for the downward movement, but then the elevator would be above. But in this case, you just need the one.
Yep, you just need it. Exactly. So
yeah, that's why we need Gustav.
Yep. To remind us of what these medical terms are. So it is technically a 9-DOF arm now. So now this is not the first one. I think it's been over a year. There's another Chinese bot out there which is called TLI bot that I discovered. Someone sent me a link like 2 weeks ago. I looked at it and I'm like, oh wow, holy cow, it's got the scapula, and it had 2 degrees of freedom there as well. Range a little bit different, but but still kind of similar idea was going on. So this is not the first one, and a lot of them are looking at it. I think DLR had something, but it might have been like an 8-axis one, as well as KIT, Karlsruhe Institute of Technology in Germany. Both those German institutes. Well, DLR is an aerospace group, and basically it's a German version of NASA. And they also had kind of a scapula light, I guess you would say, that they were able to get it to do more or less the hug as opposed to the shrug. Because for many cases, that's what everyone wants to do, is to be able to reach forward. So moving on, we can take one last view here to kind of get an idea of exactly what, I guess, would you call that the clavicle that's sort of out there? Or
I guess that would be the equivalent of the clavicle at the front.
Yeah, kind of looks like, which gives you that nice shape, especially that bodybuilder kind of shape that someone like Arnold or others would have when they get that all developed. Exactly. But the other reason I was looking at is I'm now going to pivot.
Okay, so I have a question at this point for Gustav specifically, because we keep comparing these bots to the humanoid, to the human body, because they're humanoid bots. So there's a lot of features in our skeletal system that have evolved because they're also protecting a lot of parts like our nervous system, our circulatory system, organs, soft organs. So the entire upper structure with our shoulder blades, our clavicle, our rib cage is also a product of evolution, because it needed to evolve in order to protect the fine, soft, tender organs and other parts of our body, which really get us working, which is not needed in bots.
Exactly. So you have to be careful how much biomimicry you do. Yes.
Right. And the scapula originally came from, like lizards or early amphibians, where the scapulas were sometimes almost fused at the back, so they couldn't really move the scapulas individually. At least that's the way I think it was. So they're quite stiff when it comes, similar to our pelvis,
The
you'd
pelvis,
say,
yep.
for the scapulas. But then as we kind of evolved, they lost this linkage and the arms could come down. So the early ones, they walk like this, you remember? And then they kind of come down towards the tetrapod. So this was already...
Was it this bot that also had the four, or was it another bot I saw recently that had kind of that transition from a...
and I think that was just a unitary...
Or was it a unitary?
Yeah.
The scary bot when they kind of made
the freaky scary bot.
Yeah. And the thing with them is ideally our joints are supposed to be ball and socket joints. But if you really sit down and imagine designing a ball and socket joint that would be able to move, you begin to realize I have a cup and it's going to stay in the cup, and the cup takes up an entire hemisphere. So that already limits the range of motion that you have. And then you stick a shaft out of that thing and that limits it even more. So the one way to kind of extend the range of motion is to have a scapula that does something like that. It basically allows you to improve it, which is probably why evolution said, hey, that's how we solve that problem. So if you're actually going to go to a ball and socket joint, it might be that you have to consider the scapula as a way of getting around that, because it's a major engineering problem and then no one really knows how to extend it beyond. Theoretically, you can get 180 degrees. The reality is you might be more like 120 because you need structures of certain thicknesses. And so you can't have a cup that's exactly 180 degrees. It's going to have to be like 185 or 190 just to make sure it stays in place. And then your shaft can't be infinitely thin. It's going to have some size, and that's going to bump up in there. So
and when it comes to
that could be a reason for that. Or at least from the standpoint of evolution, because
and the protective aspects is probably true. I mean, we have the vessels and the nerves are on this side looking from the back, so we'll protect them and we keep them on the inside of the arm. So whenever we have a cut or something here, it's not as detrimental to our sensation and our
also
our
all the blood vessels going up and down to our brain.
Exactly. So they are covered
through
down,
the clavicle, right?
And not going late and talking about fighting bots. I mean, boxers would use the elevation of their scapula to kind of defend. I'm not a good boxer, but that is part of like defending yourself when you
exactly.
Back. So
and it allows you to get into places that are a little bit tight, and again extend your reach. There's a myriad of advantages to doing it. The question, but I'm more in the O camp. You know, it's optional because it makes life easier, but it's definitely not IRN.
For the show bot, I say it's in the NI part. I mean, if you really wanted to communicate with and be as human as possible, and the whole swaying of the hips is meant to do that.
If you're putting this on Disney theme parks, then you want that.
But then when you go to heavy lifting and only doing heavy lifting, maybe even just screwing in the bolts.
Then you want a fusion operation like what you guys do all the time, right?
Exactly. You could actually do scapular fusions. It's very uncommon, but in certain conditions where you have like a wing,
very uncomfortable,
then you can kind of fuse it, and then you would be quite hindered.
Or if you have a frozen shoulder.
Well, that's further out. But still.
All right. So moving on, I'm going to try to go to the head. And so here's like the last view that we can kind of see of the clavicle and all that area in there to get an idea of how those mechanisms work. But I was then trying to figure out what's going on with the head. And the head has turned out to be like the hardest part for me because I still not 100% sure I got this right. So everything you say, you definitely say with a grain of salt. And a lot of it is like trying to find where the head actuators are. So I think, if we look at this video here, this is like the closest video that is able to see where there was some movement of the head. And it's hard to really tell because the body's moving as well. So you're not sure if you're seeing the head move because the body is moving or not. But I think I see the head definitely doing the X back and forth, which would be kind of that side to side nodding or the maybe. And then I think I might see it rotating in the Z up in the cranium, not necessarily down at the neck. I think that's what I'm seeing. And hopefully I'm not being fooled. Because that's kind of changed my calculus and thoughts of what's going on, but it's made me even more confused, and we'll sort of see why. I
don't see the chin moving up and down so much on the Z
axis. But it can do it.
It could be an illusion, optical illusion, because
there's another one that you can see that the chin's going around. So it sort of depends upon where you want to have the pivots. Do you want to have all the rotation in the head, or do you want to move around? And we're going to see that the rotation that you're looking at is looking forward. That while the chin may not go down, the whole neck can because they have a rotation. But first I want to focus on the Z. So right down here where I sort of highlighted it, it looks like there could be an actuator down in there, which I could not see from other views. And I looked at it, it's like, well, it's there, but it means it's probably buried way down in here. Hopefully it's not taking up some space, or is that just an attachment point? I'm not 100% certain. And right now I'm leaning towards, I'm not sure about that rotating there, because it appeared like the rotation was happening up high and not down low. And so this is sort of what I think it has, is it's got a rotation along the Y here, and that's clear. We're going to see that actuator that sticks out. I'm not sure about this one here, and we see what appears to be two linear axes going on up there. I mean, you can make scaffolding and structure that's a lot thinner and doesn't look so big and hefty like that. And the only reason you don't want to do it is you're doing the same trick that you're doing with the wrist and the ankles, is you've got a cardon joint up there that gives you two rotations. Mm-hmm. But the rotation would be a second one in the Y and also the X that it would be nice to have. Mm-hmm. So it's like, well, okay, that's kind of interesting. And then they must have the Z down there. So I thought it was a 4-axis. But one of the reasons why I don't think it's 4 axes is once you add up all the degrees of freedom they have, I come up with 83 DOFs. And they're saying it's only 82. Mm. So that means, and the DOFs, all the other DOFs I'm 100% sure about, except here. So it probably is only 3 DOF, and it's doing the Z rotation up there. Yeah, and so we'll kind of look at some of the other pictures here. So I'll take that away so we can kind of see a little bit of the highlighting in here. So when we go and look around, we'll see the others. So,
is it the same actuator? You see the dark slot on this actuator that's further down, that's moving the scapula. It looks like what you're having in the neck.
Yeah.
So the dark slot on the
yeah. It looks like that.
So
I mean, it looks like one of those, exactly. So it kind of looks like this. So you can see this big actuator here. That's the Y. That's the one that's making the head lean forward, and that makes sense. I don't think you really want your head to go down like this, because you don't want to bury your chin in your neck to look down. You don't want to crane over a little bit. And so that means your field of view is a little bit better. It's like, oh, okay. But that's a big actuator. I mean, look at the size of that thing. It's like, it's built to carry something massive, and your head should not be that massive. It's like, well, that's a pretty big one. And again, I was looking down here and I could not really see another actuator for that Z rotation. And I think that front view was tricking me a little bit into thinking that. So when you go over to here, really yeah. So again, I don't quite see what's going on there. And you're looking at that, and it's like, again, I see two linear actuators. I see what look like maybe a Heim joint or a pin joint there. Could be just that they're a pin joint, and it's pretty big if it's a linear axis. So I'm kind of highlighting what's there for you to get an idea of what possibly could be there. So I could be fooled a little bit. I mean, there's a couple of ways that they could be doing it. Is like, oh, wait a minute. It's not really a quadrilateral that they're having for it, or you could just actuate one side. One could be a dummy, and it's just one of them that's going up for some reason to give you that X back and forth. And then it's got a big actuator in there, which is the one that's rotating around, which is why that Z or that Y actuator has to be so big, because it's carrying a heavy neck and something heavy in the head. And who knows if they've got other processing or other stuff in the head that also adds a little bit of mass. So I was just looking at that overall and a bit confused. And I'm going to lean towards they've got a Z rotation in the head, though I can't confirm it because I can't see it. And they're doing something tricky to get the X. But this thing here, that yellow part there, that it's kind of throwing me off. Well done, well played. I mean, we can see it's a pin joint there that they're actually able to get something out there, and I can't figure it out. So bravo to the XPeng engineering team. I go down in defeat. And again, so we can kind of see, what could be going on there, the kind of rotation that's happening up there. Now, let's move on to, if we want to start talking about in and out right now, this gets wild. Because this is the waist.
That's some serious hardware.
Yes, this is the waist. So let's take a look, again, showing how the waist is going on. Now, I'm going to let it run long enough that you guys for sure, and hopefully our viewers, will be so familiar with this kind of mechanism. You've seen something like this more than enough times. Is this a kidney style waist?
I mean, what would happen if you only actuate one?
So, the kidney style waist is technically an RSU, rotational spherical universal, which means they're using rotational actuators for the kidneys, because the kidneys are like these nice little round things are up there. Do you see any rotational axes there, actuators right now?
It's if they are very high up in the image. Yeah, I mean, that's the only place I could imagine that it's at.
Well, they're there, but there's something else. But we definitely see linear actuators. And as we go through, I'm going to contrast it to the old one. So what I want you to see, there's a bunch of things that are going on here that I think are really going to get pointed out. They're nice. The first big structure you can see in the metal is basically a cross that's in there. That is like your universal joint or your cardan joint right there, which has two axes, which I'll highlight. And then you have the actuators on the side, which they're not going differential right now, so you can only really see one motion. But when it does the movement, it's exposing another actuator that will be pretty obvious, and also one that's down here. So there's a lot of actuators going on here, and one that we haven't even seen that's part of the waist. So, and the other thing I want everyone to look at is that you see this tie rod that's going up and down. I want you to notice that if you look at the sphere that they're connected to, you notice how it kind of orbits on there?
Rotating. Yeah.
I'm going to get into that because you really don't want it doing that. That's unnecessary motion. So either the animators put it in for fun, or however they went through with their math, it ended up kind of doing that. But I'm glad that they show it. See, this is what we're going to get through. Yeah, so we'll get to the whole thing. So this is technically an SPU kind of joint. It's very much like the Optimus wrist. Expanded. So the first thing we're going to see here is that there's definitely an actuator here, and there's definitely an actuator here. So we got a blue and we've got a green actuator, but it has nothing to do with the motion that we just saw. The motion we saw was purely these linear actuators on the side. And so this is the parallel actuation strategy that is giving us a couple degrees of freedom. So what we can see is that green actuator that was down there is giving this Y rotation, which is basically allowing the bot to lean forward. And then you get this Z actuator, which is taking the upper part of the torso and rotating the whole upper part of the torso. Now we have to take this probably a little bit further and actually look at the overall structure, because there's yet another Z actuator that we couldn't see in there, and that's way down here in the pelvis. So down here in the pelvis is a Z actuator. Here's that Y actuator that we were looking at. We get the parallel actuation, which creates an X rotation about that cardan joint, and also the Y. Basically, we were seeing the Y, we were not seeing the X, and then a Z up there. So now look at this. So this is my serial parallel notation. So it's Z-Y-XY-Z. So how many letters are there?
5.
5. Of all the waste, I think that the one of the most degrees of freedom I ever saw was like Phoenix, and that was just a render. I don't think I've ever seen it live. Most of the others go anywhere from 0 to 3, with this kidney style waist being kind of popular. With Boston Dynamics is doing it, Limex is doing it. Figure One did it for the very first one, but then decided not to. And also Limex, these guys, and Unitree. Unitree has it. Now, it turns out those kidney style waists, as much as they're nice for being able to get that XY and it's very compact and around like that, they have mechanical issues. Part of it coming down to the actual tie rods that are going on there. So some issues that are happening in there. But for the most part, everyone's saying 2 degrees of freedom or 3 degrees of freedom. That's been the debate. These guys are going for 5. Why are they doing that? Any idea?
Want to do the Mamba?
Well, okay. So the first thing I want to do is compare this to the original iron. So the original iron, you see, it is your classical kidney style waist, and it's only 3 axes, 3 degrees of freedom. Now, what ended up happening is the CEO has mentioned that the reason why this bot's able to walk that way is because of the spine. So they don't call it a waist. They're saying that it's actually a spine. And I kind of agree with that terminology because they're getting a lot closer to it. It's not, a spine is very different, as our spine. However, the amount of movement they've decided, and maybe it's right to be able to get that kind of degree of control to be so convincing, you need to have those other 2 degrees of freedom. So if we go with Gustav that you want it to be humanly convincing, those joints are either indispensable or needed. But Roy and you would be like completely unnecessary and maybe toxic, because do you really need that many degrees of freedom in there? And that's why I think this is an interesting discussion, is like they're causing us to think about this. I would have to say that given the fact that they get 5 degrees of freedom, they figured out how to do it in the most compact format that I've seen. Part of the trick might have been going to the linear axes. They replaced the kidneys, the rotary ones, with the linear ones. And I think it's because the linear ones give them more stiffness and more reliability. But again, my concern has always been, and I think it has come. Oh, let's go back on up. Is again when we look right here, the tie rod that's going on up there and how it rotates. So I've mentioned this before. Is that what you have? Is you have a 2-axis problem. Is that you've got 2 degrees of freedom here, and you're going out of plane with your motion. So the actuators have to be able to adapt to the fact that they're not just moving in this way, but they're moving that way. So you need to have some sort of joint that allows you to do it. But it's really a 2-axis problem. And they're solving it with a 3-axis solution, which is what a sphere does. And the thing is, we don't have really good 2-axis solutions. We've got a good 1-axis solution and a good 3-axis, but we don't have ones without additional complexity. We do, the cardon joint, but that's basically cheating and putting two pin joints together at cross purposes. And so they put that in there, and that usually in all the animations and everyone that you see, this thing is straight on and doesn't rotate. So that's your unconstrained degree of freedom. It's along that. It causes twisting. Go to the Tesla shop and look at Optimus and everything that's set up, and you'll see the same thing, that it goes over until it can find a resting point. And that resting point is usually this ring rubbing up against that nut. It's not good. It's not meant that way. The other thing that's a problem is that, these joints are designed around the idea of a nut in there turning that drives a screw. Now, I can either turn a nut and make my screw move, or I can turn the screw and make my screw move. So if I take my screw and actually turn it a little bit, it's going to create an offset that I don't want. And there is a solution to this. And if you actually look, Tesla has done that better in the actual bot than what we actually see in the demo showrooms. Because the way you solve it is the shaft that's coming out, you don't make it circular. You make it square in shape. And that's one way that when it comes out, it cannot turn in that direction. So I'm really surprised to do that, because again, that is going to cause a little bit of wobble, and it's going to make it very difficult for you to see what's going on. But I believe going with this solves what might be some of the problems that others are seeing with their kidney waste as being actually the failure points for the robots. That's the thing that's causing the most downtime. Yeah. Okay. And we're only halfway through, Royden. All right.
But then again, I mean, I can't help but wonder about the life of these.
Yeah, I mean, that's what it comes down to. And if they're
there's going to be so
only
much of
gonna
friction,
dance
and
now and
robots are
then.
dealing with this.
Yeah.
And
Okay. So I think all right. I'm going to just go ahead and mute that. So now here we see actually the bot with all the skin covering off, so we can see it actually moving around there. I mean, this still goes to, I'm not sure, that could be a human head in there. So they may have, because they've covered it up, I think we should be very suspicious that there's actually more going.
The movement of these of the hips is really impressive, and then
Yes.
I think about what you said about the spine.
If you don't have the spine, then the whole thorax would kind of tip over.
Raise a lot less.
So that's why you need to kind of.
You will have people arguing. It's like, yeah, but you can do that with 3 degrees of freedom. Do you really need the rest? And it's like, maybe you do to be a convincing human.
If you want to twerk, you need the spine.
Yeah, I think you need the whole thing. So I'm glad that they played around with it, because it's causing me to kind of reconsider and think of these things, and what are the degrees of freedom you need. But again, it comes down to, if you're just putting it on the factory floor, we don't need to twerk. So
Maybe.
and again, it's going to be a failure point,
Yeah.
potentially.
Do you think that you doing these things, like really pushing it when it comes to doing actual useful work, they don't really need this probably to move boxes around? But if they do this and kind of develop the actuators, will that push technology forward so that the same type of design can in the future be used for heavy work? Or will there still be a durability issue, like, oh, that's not going to solve that problem? Or how do you see those kind of things? Because I don't really know.
Yeah. That's the whole thing, is you got to experiment and find out. Is if no one takes the brave step of testing it, we're not going to get that data to be able to know. So it's easy to sit here in our armchairs and hypothesize all day, but in the end, someone's going to go out and try it. And I'm glad to see this. So I don't know that I would encourage other people to do it. It's like, wait and see how it goes. But if you are Disney and you're thinking, we're going to have humanoids walking around on the parks and we want them to be convincing, you're like, yeah, this is what we have to do. And the thing is, so long as you don't have to like be lifting up kids or something like that and carrying any payload, you might say, that's fine. We can do it. The payload is the bot. That's it. Nothing else. And then you'll be fine. Or you have it carrying some balloons, and that makes it a little bit easier, right? Because
or you
it's
have
not a
something like
payload.
companion bots.
Yes. Yeah. Well, yeah, potentially on that. Now, so just to jump into the controversy here a little bit more, I'm kind of suspicious about this wheelchair over here and whether that kind of goes to the conspiracy theories that it really was a person in there. But other than that, and you'll notice they kind of cover it up with, that just kind of slipped through here. So, boy, let's just lean into the conspiracies. Oh, no, it kind of shows up for a while. But we get an idea of what they're doing. And fortunately from this, I can examine parts of the bot that we couldn't examine from the presentation because they didn't show everything from the hip down. And so that'll make it a little bit more interesting. All right. So, but I think before we go there, I didn't want to put this at the end because otherwise poor Gustav would be sitting here and not being able to talk about what is literally
the only thing that matters.
Yes, the only thing that matters, the Dex. And it does kind of matter. So we didn't get much of a presentation. So we get to see a picture here. I'm assuming that is not a hearing aid that it's holding there, but is actually maybe one of the actuators for the IP joints.
There was actually a video of someone where they had the hand. Do you have that on the pedestal?
Yes. I got a clip from that. So the main thing is to compare the two. And this is why I was like, oh, did they put the first one in there? Because this is what it's supposed to look like way on the right. That's a CGI. In the middle is the current iron. And we can see exactly how the joints are done for the wrist in there. And we can see something poking out there on the left side. So it turns out, those things are going to be the hardest parts to cover up because it's already breaking through the material layer. We can kind of see that there. But we can see that the hand on the left.
The back of the knee.
Right. The hand on the left is definitely the original hand. It's not the new one. However, the forearm is probably the new one because I think the old forearm is a bit bulkier and the new one is thinner enough to go in there. So the hand wasn't ready. So all they could do is show the CGI of what the hand is going to be and just talk about it being nice and saying it's 22 DOF. And we know nothing more than that. All we can do is speculate. So this is like one nice image of that. And what can you glean from this, Gustav?
It's a CGI thing. I like that they appear to copy the hand with the M. We keep talking about them others putting the MP joint too far out. So here it's actually hidden beneath the skin.
Too well hidden. Okay.
Yeah, too well hidden. Probably it's going to be tricky. And I don't know if it's hard to tell, but it looks like the fingers are different sizes.
Yeah.
This actuator is really, or whatever it's supposed to be, if it's just a joint or if that is actually an actuator in the same style as the Wuji hand. But
I think it's different than the Wuji hand. The Wuji hand is going in the phalanx.
Yeah.
Whereas I think Dexel was the one that also did them like right at the joints.
Oh yeah.
But these look like a little bit bigger than the ones that are Dexel. So I think that's where the motors are. And here's where we can kind of tell is that this is the picture you're talking about. This is Fred Lambert of Electric was invited over there for the presentation. So he got this, and I was looking at that. And my overall feeling is that may not even be a prototype. That might be. I don't think it's working at all because it doesn't look like real motors there. I think it's something that's been 3D printed out to give everyone an idea of proportion and what they would like it to look like. They may have some sort of glove material over it because we can see it's crimped a little bit. So it looks like maybe it can move, but I don't think it's actually working.
No. And if they're going to put a glove on it, they should really cover the joints as well.
Yeah.
Things are get stuck. You're going to get the
yeah. This is the thing is someone was claiming that they had an IP68 hand. And it was like, and they were putting underwater and stuff like that, but they had the IP joints extremely exposed, which means also, and part of the IP rating is not just that it's waterproof, but that things can't get stuck in there, like fabrics, like fingers, like dust, like food particles and stuff. It's like, okay, it's not getting in your motors, but it's still getting in the overall mechanisms and gumming them up. So I agree with you is that if you want to make sure you have full IP protection, you'd want to have that covered up. Now, looking at that, they said 22 DOF. Can we surmise at all what those 22 DOF are?
Yeah, it's hard. I mean, you could just guess because you can't really see what they're doing with the CMC or the base of the thumb. There's only one visible joint for the
Yes,
thumb.
exactly.
I'm guessing there's an MP joint in there.
Yep,
There
I
is
am
also
too.
MP joint
Yep.
here.
Yeah,
And then I guess perhaps they're adding the
CMC
fifth.
down there, but that CMC's got to be 3 DOF. That's a tall order.
Yeah.
Right. So when you get down to there, it's like, oh, we're adding one more, and that whole thing is we're somehow getting another 3 down there.
It might be so. I cheat sometimes. I usually call this the MP joint, like a hinge joint, but in reality, it is a slight egg-shaped joint, as we call
Right.
them, like this one. So there is some slight ab and adduction in this joint. Most of us just use it as a hinge, similar to these joints, but there could be some ab and adduction here as well, not just a flexion extension. So maybe they're adding that part. Not that I don't think they should.
Yeah.
But it helped a little bit in some.
And I think that's what the Tesla bot hand is doing, the V2 hand. When you look at the thumb, is they clearly have something which is acting like an ab adductor there. And they get some other motion that I haven't quite. I mean, there's 2 of the motions I've kind of been able to figure out. I'm not sure how they get the 3, but they keep on saying it's a 22 DOF hand from Tesla, and we know the 22nd one is over in the 5th metacarpal. That's really where you get it. So they must be doing the same thing then. They must have a metacarpal.
I mean, the whole talk, I listened to the talk and I really liked it. It felt like it was a combination of everything that Elon kind of says and presents, and a lot of what we have been talking about in like, what would a nice hand be, and the same going for vision. So the whole talk seemed like we want to be like them kind of talk. And maybe this, they have 22, we're gonna have 22 as well for the hand.
Yeah, exactly.
We're not gonna say what it is, we're just gonna say that we have that to kind of
and how they're going to do it, it looks like it's going to be done with a bunch of actuators, because we're not seeing any indication that there would be a forearm that would have tendon drives in there. So it's going to be mechanically driven. That's kind of the impression I get from it. And then Fred also got that picture there. So this is where you get an idea of what those IP joints look like and the controllers that are on there and all. So I
don't understand them. I mean, you have the cable going into one end. Where is the actual actuating? Is it?
I think what it is that that's the axis of actuation. So I think you see 2 halves. You see like the silver half down here, and then you've got this kind of clay colored one up here, beige colored that rotates. And then you see these 2 square parts that come out. That's probably where you connect the phalanx on there. Now, the thing that's going to be tricky is like, this is all very nice that this cable runs along here. But remember, we have 2 IP joints. We got one up here. How does the cable from that IP joint get from here across that on down? Does it really just kind of go over the top and through? Or are they thinking of some other method of being able to route it? So you won't be able to do like you do with your other actuators where you have a hollow shaft. So it's probably being routed over the top some way. So we know nothing about it. We have no idea of the range of motion. We have no idea of the grip strength, anything like that. So at this point, it may be that the hand is going to look very convincing. It's going to look human. It's going to be able to do all the same gestures. And the thing to remember about the Tesla bot hand that we saw, it was able to play air guitar. And we kind of know it can do air guitar, even though we've noticed that its fingers don't curl up quite correct. But there's a big difference between playing air guitar and playing the real guitar. And that is like the pressure and everything else you have to put on there. So I'm not convinced that Optimus could play a real guitar at this point. I'm not convinced that this one would be able to do much more than convince us it's able to do all the gestures. Say, how many different gestures that everyone have out there that when they show the hand gestures? I bet it can do all those. I just can't actually do it in practice.
No.
Where do you think this would rank on the Kapanji scale?
Well, I mean, since we can't really tell, but we can't really see where it's going, if it's moving here at all. But since they're saying 22 DOF, or it should be able to reach at least some way across. But
the only way you could cheat on the hand is if somehow you include the wrist in there. but most people don't. So I mean that would be and no,
How do you mean?
they don't. They couldn't because they're saying 82 degrees of freedom.
Oh, okay.
And 22 there. No, strike that completely. They're counting everything with the digits. They are not including that. Otherwise, they would get like to 80 DOF and not 82 or 78 actually. So and I'm pretty sure I've counted all the other DOFs correctly. So yeah, that's all there. I mean, unless they have a bunch of the other metacarpals that are just kind of moving around a little bit, but if they're getting the full movement in the thumb, they should be able to get a 10 on the Kapunji. We don't know. It depends on the range of motion. I mean, it's like, just because you can do abduction doesn't mean you can do the entire scale.
And then actually grasping something with strength.
Yeah, right.
Touching the little finger and actually being able to hold a paper. But I mean, if they're planning on having these in the showrooms, if that is their main goal at the moment, they should at least be able to hand out pamphlets or something. So it's not just air guitar. They should be able to have a slight grip. Right. Maybe open the door, but probably not. I don't know.
Right. Now, kind of going on that vein about that. This is something that really, I think, surprised all of us. Is that he was talking about the commercialization, and he was very frank. I mean, I love the fact that he was like, we already tried it in the factory, and we found out that it doesn't work. Yeah, and it was like the hand breaks. I'm like, and the hand is breaking. That's a mechanical hand. There's no tendons in there. And it's just because of the vibration of using a screw gun or tightening, which it's like, wow, that's amazing. So they're like, we're not going to put it in the factory right now because the return on investment's not there. You're still better with the humans. And then he talked about, guess what? We're not going to put it in the home either. And he had like a bunch of reasons, from safety and stuff like that. The fact that your homes are very diverse, and it has to get to know your home. And I'm like, well, wait a minute. That's going to be part of the intelligence, is that I really think you should, that's not the hard part. The fact that your home is diverse and it doesn't know it. It will map it really quickly. It's just lifting up a knife like that and cutting is going to be very hard. So, he said that we're not going to do that right away, partly because it's very difficult from the autonomy, but we're going to go right to this, which is tour guides, salespeople, and receptionists. And none of them have to carry anything. All I have to do is point their hands, and their gestures have to be very human-like. So again, no payload. That hand is going to be nice, but I don't think it's going to be a functional hand, is my guess.
No. I mean, functional in a way that it can move, I hope. Or do you mean that it's just going to be a solid hand?
It's just that I wouldn't use it to like bring in my groceries or pick up I just don't think it'll have the payload capability. It may not have the dexterity. Maybe it can like play a soft piano or something like that, but I'm not convinced of what they have, that those micro drives will be able to give the grip strength that you would need, and then of course the durability and everything else. So, and they're kind of like, hey, they're literally shrugging their shoulders and saying, we don't care about that, because if it's just about pointing and doing stuff like that, you don't need it. You don't need that grip strength. What they're going for is that you really think that's a person in there. And this is something that I think I pointed out on John's channel, that, AI has been saying, oh my God, the AI in the robots is going to take away all our jobs. And if you actually look at AI right now, the only job it's really taken away is probably lawyers, because it's like really good at doing stuff like that.
A lot of white collar jobs.
Yeah, but the white collar jobs are mainly lawyers are taking away. And now it looks like the job that the robot's going to take away is not actually the factory workers. It's not going to be the blue collar workers that I call the salt of the earth, the people who will actually build and do things and actually allow civilization to exist. They're taking it away from the salespeople, the car sealers. They're getting rid. So, I mean, everyone should embrace AI, because like the two professions that are most hated are lawyers and car salesmen, right? And we're getting rid of them. Okay, I mean, this is like out of Douglas Adams. Remember didn't they have one of them like the C ones where they put like, was it the people who were the phone sanitizers?
They sent them in one.
Like all the people that were absolutely useless, the lawyers, they put all those people in there. It's like, this is great, man. We should embrace this. They're getting rid of the right people, the right class, So, that's. I guess we can be encouraged about that. So.
But it does seem to be an awful lot of over-engineering for
Yeah.
Yeah, and that's
for
what I
that
mean. It
purpose,
has
also.
to be kind of, they have to have the vision that, okay, this will then be more easily transferred into a more useful product. I mean, if this costs 200,000 US, I mean,
Yeah.
Yeah,
can't be
yeah,
worth
yeah.
it.
It's
Or
not
maybe
going
it
to be
is.
worth it to be a salesperson or
No.
salesman. Yeah, exactly. But they're talking about mass production starting end of 2026. Kind of a realistic time frame. We don't know exactly what that is. They didn't say much about cost, but the feeling is like, maybe the cost will come down. It's going to be hard because their bomb is going to be crazy with all those additional axes. But yeah, we'll go ahead and see where they can do it. Now, they didn't rule out manufacturing. They just said, for now, we're not going to do it. The home, for now, we're not going to do it because we just don't believe we're ready, and it will take a few years to get there.
Yeah, I mean, you don't have to. Tesla has the approach of we're going to do everything ourselves. And I mean, they just provide the hardware and then someone else provides the brain, perhaps.
I mean, honestly,
Or
if you
the
look
hand.
at the entire presentation, I think the wow factor was the catwalk.
Yeah.
Right.
Yeah.
And
you want to know how it did that catwalk?
Sorry?
And now we're going to figure out how it did the catwalk.
Yeah. But if you take the catwalk away, how much of substance really is there?
Well, the thing to remember is that as we're going to start seeing, the original iron in this one uses a lot of linear actuators. Actually, they added a lot more linear actuators, but I didn't expect it. The original one had a rotary actuator in the elbow, and now it has a linear actuator like Optimus. So and in the waist, they get rid of them. A little bit of changes in the pelvis, but they're kind of embracing that. And we have yet to see a linear actuated bot walk really fast or run. They give us hints because they might be able to dance and do a few things that you would say, oh, that must mean you must be able to walk. But no one has demonstrated that. Pronic hasn't shown it. Tesla hasn't shown it. We haven't seen it here from Iron. And also Neura. None of them are moving fast. So if you want to convince people that you are very human-like, one way is like you do these exotic kung fu moves or like this other stuff, which some people would say, it's so superhuman, I can't believe it. A catwalk is very slow. So everyone is focusing on how realistic the gait is and not realizing it's not very fast. So it was a very because they literally leaned into their strength. And their strength was that we have all this dexterity and everything else that we can do the swaying and all that and take your mind off the fact that it can't walk very fast. And maybe that's sufficient for these sales room kind of applications or being a tour guide where the idea is not to like be bustling around really quickly like you would on the shop floor. But there's some things that they mixed up from the original one that has helped them make it look more human-like and make it easier for the coverings. And that's why I want to concentrate now on the knees.
These knees.
The knees, yes. So on the left side is the original iron. And this is like one of the few glimpses I could get of the original iron kind of in motion, where I've circled where the knee joint is. And you can see the actuator that's poking up there for the knee joint. And it's actually a 4-bar mechanism in there for doing it. Very similar to what Tesla does with their knee, because they want to linearize the torque curve. It flattens it out, makes it a lot better in the range of motion. And this is what's known as an inverted Herkins mechanism, 4-bar mechanism. That is a specific mechanism that actually has a part of its motion which is straight. It's like just amazing that it happens. Like when you do the math, you're like, oh my God, it really is a straight line. So that's there. The problem is when it gets into full flexion like that, it really pokes out. I mean, you can see that thing. So you can imagine, and if I was putting like a pant leg or something like that over, that thing's going to come out. Now, it turns out when it's standing up straight, that thing kind of hides itself really neatly in there. You almost don't notice it. But what they decided to do is that rather than having this thing up here in your quadriceps is to actually put it back in the hamstring. So they reversed it. So Tesla and everyone else usually puts that knee one up at the top. It's not in the back. The original one, they actually had 2 linear actuators back there, and we'll sort of see how that goes when it comes to the pelvis. So they switched the order, and you can see this inverted Herkins is now down in the back part of the knee rather than the front. And this actuator that we see over here in the front is actually going to be the flexure now. And we're going to see the change that they made there. Okay, so as a result of that, we can sort of see them, again, poking out in the back. And sure enough, because I was wondering, what's that pokey thing coming on out there at first? And when I finally saw that, I was like, great. Because I was wondering where that was coming from. And it's very clearly from that. That's the other reason why. And this is why I was like, man, I wasn't 100% sure it could be the first one, because you see how convincing the kneecaps are. It's like, the only way you can have the kneecaps is there can't be anything. And now this little white thing you're seeing here, that's actually from the dolly. That's not part of the robot. There is nothing there. So they can put the padding there and you wouldn't see anything. And I'm thinking, but if we go back to the original one, I mean, that thing's going to poke. There's no way you're getting away with kneecap there, making it look real. So we can see that sure enough, it fits in there. And again, we can see the silhouetting along here where you can sort of see parts of the calves and everything else. So that's what they've done to change up the knee. And also these actuators seem to be a little bit smaller than the original one. So either they're more powerful or they don't need as much because they've changed things for other reasons. Again, if we look here at the calves, we can sort of see how slender they are. They're the same that we see in Tesla. The original iron was also done this way. This is what's known as the SPU kind of joint, spherical prismatic universal. And we can see it poking out here just a little bit, feel it closely. And they put some nice padding back there because you see there really is nothing behind there. So they had to put some padding to give you the illusion of a calf. Here's the OG. These again are from Frederick Lambert's video. I was able to grab them. Thank you very much. These Crocs look interesting because it almost looks like a split toe in the original one. I wonder if they did something down there to help a little bit with compliance. I don't know how much of that is actually the part of a toe box. I don't think the new one has necessarily that split toe. It seemed to have a little bit of a compliant toe box, but it wasn't obvious. We weren't really seeing it the way we see in others. So, but we can see that these calf muscles, if you want to think of them that way, are much thinner, way more elegant than they are in the original. Now the fun part. So this is the OG. This is the original iron from a year ago. And this was like a nice image that someone took at a trade fair somewhere. And I was having a hard time figuring out what was going on because the silver piece you see here is actually like a plastic piece they put in there for shipping to keep it in place. It's actually not part of the robot. It's just there to make sure it doesn't swing around. So you have to realize that, don't let that trick you and fool you, because when you see other images, you realize it's not there. And the way this thing works is you have a rotation at the top. So basically it's an RAF, a RAF. So the rotation is first on the Z here, and they have a cardan joint, which gives you the rotation here that would be like your flexion, and then also abduction along here. And it's not obvious, but there's actually two linear actuators. This linear actuator is part of the knee. There's nothing to do with flexion or anything else. So there's a linear actuator back here where we can kind of see the mechanism that kind of pokes up here. There's one on the other side. And through that, same strategy that we see in the wrist and everywhere else, differential actuation will give you the abduction. Together will give you torque sharing on the flexion. So it means it's like it's going to be really strong on that. And so it's very similar to, I think, what Aptronic does something similar to this. So rotation first and everything else after. And as we know, everyone's gone to like the far. They're going to like, wait a minute. What we want to have is we want to have flexion first. On the new one, a little bit hard to sort of see here where everything is. Everything got changed. And now, Royden, you're finally going to have your question answered. Is like this green part here, the abductor, that is the buttocks. That's what they had to put a lot of padding around. And it's not something they put there to make it look like it was human. It's something they had to figure, how do we put it around there so it doesn't jut out so much that you realize it's actually a motor there. So that was probably pretty tricky for them to do it. So the abductor
is a really big one.
It's a really big one. Now, the difference is that Tesla has one, Figure also has one, but Tesla's is up very high. It's almost in the small of the back. So if you tried giving Optimus a buttocks, it would be like, what? Why is it in the small of the back? The same problem with Figure is it's like low. It's like down in the leg itself, and it wouldn't look right. They have it in such a natural position that you could trick someone. So I don't think Figure or Optimus, the current ones, could fool someone to that extent, because you would kind of notice there's something a little bit off with the movement. But that's right there. So that means A comes first, R comes second, and then F comes second. So this is an ARF, which is pretty much actually the same as Optimus, but there's something they've done a little bit different than Optimus. So It's almost the same up there. And again, this rotation here is new. So they took out a linear to put in a rotation. So that's the only place where they threw out a linear to throw in a rotation that they didn't have before. Otherwise, they've been throwing out rotaries all over the place. Okay, now if we kind of look at the mechanism. Yeah, right.
No, I'll come back to it because you're carrying on, but I want to just go back to the previous slide for something, but once you're done with this.
Sure. This one here or the one before?
No, the one before, the OG one.
This one, yes.
Yeah, and do you see Gustav, do you see the shape of this girdle-like structure in front? That's very similar to the pelvic girdle of a human.
Yeah. Yes.
Yeah, they really wanted to copy that. I don't know if it really adds anything.
Is that functional or just cosmetic?
It just looks aesthetic, I'd say, because
yes.
Okay.
They won't need a birth canal, I guess.
Yeah, exactly.
And since they don't have any muscles attaching there either, so it's
part of it might have been the aesthetic because they had this real kind of Greco-Roman aesthetic with everything and giving it the impression of these kind of muscles and shapes. So aesthetically, it was very beautiful. I was wondering about that and how much it protects certain parts of it in case it falls down. But this out here, it seemed to have absolutely no functional value.
Yeah.
And when I was looking at
structural stability either.
But I thought it was, in a sense, I thought I was seeing it underneath the skin because there was also a structure on this. And that's why I was like convinced it was the OG. That was underneath there because it seemed like there was that pelvic girdle was popping out that I wasn't expecting, but it might have been like some additional padding or some other things they had to put in there that was like, I don't know, because I can see from their what their proposal, it's not in the new one. So that's completely gone. But I'm glad you pointed that out, Roy. And it's rather interesting. I think they realized it was a design aesthetic and it was not there for engineering reasons.
Right.
And since they have this new fascia subcutaneous muscle cover, that will do the trick instead, probably.
Exactly. Everything that they need for that. So the way they actually actuate all these things is obviously the A actuator produces is that joint itself, and the same with the R. So both those form the joint. Now the flexion is happening at that point right there. And again, this is the 4-bar mechanism that forms the inverted Herkins that is now activated here by that particular flexure. And so that's how that's done. Now, so it's very similar to Optimus, but the difference is they managed to get that flexure up very, very high. And Optimus, it's very low. And that's why Optimus seems like it has its butt up in its lower back because it's really down deep. And that's why it would be very hard for Optimus to be able to trick someone by putting a suit on it that's actually a person there, because you would notice where it's articulating just does not look right. So they get that up higher, which is kind of what you'd like to do anyways. It reduces the overall mass of the movement. The only thing, and I think they have no choice but doing it this way, is that I would almost invert this mechanism and put it up there because in a sense, you're moving this very heavy mass more distally rather than proximal. But it might just be, it doesn't make sense to actually turn that mechanism. I mean, in theory, you could have it up there and have it riding along there and having that shaft pushing on down there, and then you lift it up a little bit higher. But they may have decided for packaging reasons or others, or maybe just it didn't occur to them. But I would move that up, because in a sense, Optimus made the same mistake. You know, their whole idea of doing an ARF was that, well, now the flexure doesn't have to carry the mass of the A and the R actuators. But now what you're doing is, but now you get this real heavy actuator practically down by your knee, adding a lot more distal mass than you should. So in some ways, they almost shot themselves in the foot by taking that approach. And it's the same thing. So that's the only downside of it. But you can see it moves very well, but it doesn't move fast. And so again, some more shots here. So if you had a hard time understanding, you can kind of see them in there, how it comes out. And you see it fits in just neat enough in some cases when it goes back that it doesn't poke out too much. So they really managed to get the silhouette right. And again, a close-up of that mechanism so you can see that joint is up pretty high. It's almost in line with the abduction. And if you can get that in line with the abduction, you've done a really good job.
I notice those massive actuators also kind of, you know, the grace, the grace in the human movement of the hip as you walk, the tilt. I
they
think
really.
if you go back to the previous slide, yeah, do you see those big actuators?
Mhm.
I think that's kind of one of the main kind of benefits of this. I would imagine. What do you
Mhm.
think?
Yeah, it really shows the tilting of the hip
Yeah.
or the
Oh, yeah.
pelvis with those.
Yeah. Oh yeah, especially with everything else going on up there. So you really have to think it's not a pelvis and a waist. It's an entire structure that you have to integrate, because there is a transition from one to the other, and part of the waist rotation is built right into that pelvis anyways. So the more you think about that as something that's totally integrated and that's different subsystems, the more likely you're going to get a more natural looking gait. And at the same time, the control system needs to think about it that way, as like whole body control, and not like, oh, we get a waist that does this thing and we get these legs that are doing these things, and we're trying to figure out how to coordinate them. If you coordinate them properly, then you can get that movement that's very natural. Now there's
How do
one
you think
other
they
trick.
solved the catwalk? Because walking on a line is, even for a human, is
It's difficult.
It's difficult.
Yeah. And go out and try it. Everyone go out and try. And again, you might notice that you have a preference leg. You have like one leg that's a lot easier, and you go for the other, and like, I don't balance so well on it. So you're literally trying to walk on a balance beam. But these control systems are really good at with all the IMUs and everything they have in there, they can really get that. So I'm not surprised. But yeah, it's a difficult challenge. In some ways, it may be more challenging in some of these other bots that we've seen, of that idea of being able to do it, because you're centered. Yeah, you don't have much leeway at that point. You are trying to come around and really balance along something fine. Whereas when you get your legs out there, they give you a lot of stability. But again, it's not walking super fast.
No, but without this whole spine that they call it, you probably wouldn't be able to. You would have this like twisting of your hips,
right.
Yeah,
which would not look as natural.
Now, as far as like the natural movement and everything, they do have one more trick up their sleeve. In their sleeve. And that is this, what they call bionic muscle. I think that's a misnomer, because these are not muscles. They don't actually provide any energy in the system. It's a covering. And, in a sense, our muscles give us, I guess, a lot of the shape of what's going on. But the reality is the muscles are, there are subcutaneous structures underneath it. And there's another structure or netting that goes around it that's known as the fascia, that I have pointed out is probably more important, or one of the most important parts of the human body that everyone ignores. So we think we have skin and muscles underneath the skin. We get this very important layer called the fascia, which puts it all together. And you're like, what is fascia? Well, it's some blood vessels, it's some nerves, it's kind of something that acts like a muscle. It's like a jack of all trades. And it's this wonderful transition that somehow is able to balance everything else that's going on in the human body. So in many ways, it connects your left foot to your right arm. Everything kind of goes through there in a way that helps get the balance. And it does other things, like it basically holds your whole body in place. And I have sort of, along with another friend of mine who is an anatomist, who talked to me about the fascia like 4 years ago and stuff like that. I'm like, you're right. That's going to be the key to the humanoids in the future, because our fascias actually provide about 10% of our force and torque in our motors when we're moving. So while our muscles do the majority of the fascia, actually contributes a little bit to it. So it's almost like that fine-tuning system that gives you that smooth movement. Now, this covering they have around there can probably do it almost from a pure mechanical, the fact that you've got a lot of stiffness in that system that will smooth everything out for you. So I'm convinced part of that nice movement they have is that whenever there's like a little jitter, that jitter kind of gets distributed very nicely throughout the whole system and you don't notice it. And everyone should be focusing on this more. It's not just a gimmick necessarily, a marketing gimmick. I think it's going to be very, very important, but it has to be done right, because as you see, they have a lot of holes in there of that structure. Part of it for flexing, and I think also because they got to move a lot of air out of this. Absolutely.
And I mean, it will protect both the internals and anyone external to these mechanisms.
Yeah,
a lot. But
I mean, look at this. The center of that is like a solar plexus. It's kind of like
Whoops. Let me get back there.
Yeah. It's structural.
I mean, parts of it are probably just to kind of make it look like our muscles. I mean, for the arms, for instance, they don't really need to do the compartments that we have, but it's a nice look, and it probably adds to the natural look when they add the cloth on top of it as well.
So it's a kind of cloth. It's 3D printed. I would like to see other structures that would almost have like some sort of cording or other stuff that goes through that might have like a little bit of tension on that that you would be able to build in, and that might really help a lot of the walking and everything else. So you can have this external compliant system that absorbs a lot of things and again smooths out a lot of the motion. So
how thick do you think this is?
It gets pretty thick in some places.
Yeah, so when they had it through, it was quite tricky.
It was, and if you look at it, it's probably thin in others where it kind of matches the structure really well. In others, there's like big voids. If you think about the void that was in there, I probably have to go right back to the very beginning. So let me get all the way back up there where we get an idea. And okay, come on, previous. Let's keep on going on up here. And it was this one right here. So you can kind of see that, they probably had to build in a lot in some places, and others would thin out.
Yeah, and I mean, it might be that they have further things that we can't see, kind of like the pubic bone that we saw on the old model. It might be that they added that underneath this bionic.
There could be. There could be some. Yeah, and that might be what was sort of tricking me is like you say, there could be a structure that's kind of built into it that provides a little bit more protection for the overall in the overall movement. But I'm not sure if they were thinking of fascia, if they were thinking on it for completely other reasons, or if they were just thinking of the covering. So if they haven't thought about the fascia, they might think about it a little bit more that, hey, you can move ahead there. And again, so this is what our fascia does. Basically, it's a sheath or band of fibers connecting material that does all sorts of stuff. So chat about it, or do a chat on it and learn about the fascia, because I think that is going to be a very, very important part for the next generation of bots. And that's the end of my presentation, believe it or not. I think we made it all the way through.
Wow.
Yeah, I mean, it's like the skin on the sausage. It's when it comes to the muscles, but then there are like different layers. So you have the one that is closest to the individual muscle, like your biceps will have its own, but then you have a thicker fascia that kind of covers the whole entirety of the arm. It kind of goes, it splits the front and the back. So it's it's definitely there. It adds problems at times if you have compartment syndrome. It's due to the fascia not giving way to increased pressures and so on.
Yeah, so it's a source of a lot of ailments. It could also be the source of a lot of cures.
Yeah,
because if you can figure out how to get your fascia back into place, it can solve lower back problems and everything else.
Yep.
I think one other problem is that sometimes the surgeons don't understand the importance of the fascia, so they'll just like cut right on through it and everything else, and don't realize that you might want to put it back intact a little bit better. And so I think
especially for if you have had a hernia, that's like the effect of having a weakened, you could call it the fascia or the aponeurosis of the belly. But as you say, also for the back, you tense up your abdominal muscles, and that transfers the force via the fascia in the back to kind of stretch out your lower back. So it is really important, and having similar covering for these bots will add stability, so you don't easily overstretch things that you don't want to be overstretched. And of course, it needs to have this pliability in other areas. So maybe that's why they have the thickening in certain areas.
I think they probably looked at it as a protective layer. And again, I'm looking at it, it's like, oh, that looks like the fascia. It's not muscles. They get kind of the wrong analogy that's in there. And again, this idea that when we walk, our legs and arms are kind of opposite in the movement. And in some ways, the fascia helps coordinate that. And so if you think about the same thing, it's like, it's like just get it with some knitting or something like that, that somehow as I put that leg forward, the other arm is going to shift around a little bit to know I have to balance it. And that's more like an analog way of balancing everything out, as opposed to something that is, digitally, that like, my control system is looking at what's going on here, and I'm going to how do I shift my mass around? And that's why you look very robotic, as opposed to something it's just like, you do that shifting, I'm going to do that shifting.
No, it's a really nice design. I mean, I hope that they go further than the than the welcoming committee at their stores.
Mhm.
Yeah.
But
I mean, think of it though. They've
I
got a
hope
really,
they
they've got a
have
captive
stores
market
outside of the U.S.
for-
or outside of China that they're going to send them to. Otherwise, I'm going to have to go over there and take a look myself.
yeah, I mean, there should be some in Europe at least.
Yeah. I think they are. But the question is whether they would send them there to their showrooms. You know,
Yeah.
it's one thing that they'll have in the because it took a while for the Tesla bot to make it up into stores outside of North America. So the Opticans, I should say, and I'm sure we'll be seeing. Did Elon mention something about the Optimus also being in showrooms at some point, showing you around?
Yeah, I think it did. Yeah.
So it probably will at some point. I mean, it's already at the Tesla diner, so it's kind of a little bit public facing already. So maybe we'll see a little bit more. And here I'm going back to my Optimus sway here to get my my blood circulating right.
I mean, it is a really strong PR bonus. Just put a bot in your shop, you will get people coming in and being interested and taking pictures with it. So the novelty of it will stick around for quite some time, I think, even if they don't get it to do heavy lifting.
Yeah, probably will.
Yeah, well, it's fascinating. It's an interesting concept. Question is, how far can they take it in terms of functionality? A, B, the hand, and C, the smarts, the AI brain.
Yeah, we don't know. Yeah. So that seems to be some in-house development that they are doing. Right down to their own chip and probably their own inference.
But they do have the advantage of vertical integration, right? For the batteries, for the chips,
right? Yes.
For a lot of the actuators, etc. Which
and it was mentioned that they did it in 2 hours. They were able to train the catwalk.
So for the dancing, at least, I think it was. Yeah. So it's quick and it's Turing. Is that and who's
Turing?
Chip?
Yep.
But
I think you showed that they're going to have like 3 Turing chips. You showed something, and I assume that they're in the torso because they kind of showed a picture of them there. So it looks like they're actually using 3. So that may say something about either they have a lot of different compute they have to do for that, or that they require that much compute. So it could be that you have different subsystems. Like one's just the language model. That's the thing that's talking to you.
Yeah.
And then, something else might be doing all body control and because usually you have like this S1, S2 kind of layer that everyone is talking about where you sort of have what your task is going to be, and then something that is just taking care of the subtask. And you want to have them in different control loops and not interfering with one another. So it might be that's why they've architected it this way.
Yeah, it's interesting indeed, because they have a lot of advantages that other bot companies don't in terms of supply chains. How far they can leverage that is going to be true test
now,
of their
I
abilities.
think they are already publicly traded. I think they have been for a while because they've been around. I think maybe 15 years or so. It's a fairly mature company. So it's not like they need any capital raises. So what this means is they won't get any capital from NVIDIA. NVIDIA is pretty much investing in every humanoid company out there that uses their stuff. So if you get an NVIDIA chip in there, more than guaranteed that at some point, if you're doing a funding round, they'll chip in a little bit. They're probably not going to, unless they say, hey, this is actually a good. But NVIDIA is not supposed to be about investing in different companies. It's supposed to be about selling a chip. So their strategic investments are to customers. They're not using anything from NVIDIA I know of, and they might even have a completely homebrew RL training set. Isaac Jim. I don't. They are not using Isaac Jim. They're probably using something around, just like I'm sure Tesla has their own physics simulator. So that's a lot to have to take on board. But if you're a mature company that's maybe been doing it for other reasons, it may be easy to pivot like Tesla was. But if you're a humanoid startup, you're saying, what am I going to use for my chip? I'm just going to use NVIDIA. What am I going to use for my training? It's like,
but like Tesla, they have a lot of
Isaac Jim.
Yeah, like Tesla, they have a lot of crossover advantages, right? Because if they're developing their own FSD version, so they'd have
and their own LLM as well.
Yeah,
they won't have an LLM in the car that you can talk to.
There's a lot of crossover applications from the car business to the bot business.
Yeah.
Well, that has been a fascinating chat. Really enlightening and educative. Thank you so much, Scott. You put in a tremendous amount of hard work as usual.
Don't worry. This, like I said, it's like the third time I had to do this hot take. So just building on what I already had. and
Well,
hopefully correcting some what might have been sort of mistakes, because that's the problem with a hot take, is that you don't have enough time to do the deep research.
Yeah. Well, third time's the product that gets
So
shipped.
yeah, the head is the head scratcher. That's the main thing.
Oh yeah.
All right. Well, we'll have to leave it there for the moment. Thank you so much, Scott and Gustav, as always. Thank you.
You're welcome.
Until next time.